We're good
All
to
right,
go.
thanks, Uli. Hi, everybody. Welcome to the Beginner's Crash Course to the Elastic Stack. My name is Lisa Jung, and I'm a developer advocate at Elastic. So last week, we kicked off the Beginner's Crash Course series, and this is a series of workshops where we delve into each product of the Elastic Stack. So by the end of it, you can identify which products of the Elastic Stack would best serve your use case and know how to get started with these products. So during the first workshop, we talked about the exciting use cases of the Elastic Stack. Then we dived straight into the architecture of Elasticsearch. Then we performed CRUD operations with Elasticsearch and Kibana. And today's workshop builds on the content of the first workshop. Now, if you missed the first one, not a big deal. On your screen, you have a link to a GitHub repo. And this repo contains a video of the first workshop, as well as two blogs that go over the same concepts. So if some of this stuff seems unfamiliar to you, then refer to this repo and get caught up afterwards. And Uli will post this link in the chat as we speak. Now, before we get started, let's do a quick recap. So if you're a developer working with data, the Elastic Stack is a great tool to have on your belt. The stack consists of 4 products: Beats, Logstash, Elasticsearch, and Kibana. And with the stack, you can take data from any source in any format, then search, analyze, and visualize it in real time. So today we'll focus on Elasticsearch, which is the heart of the Elastic Stack. And this is a search and analytics engine that powers a lot of the apps that you use today. For example, if you've ever searched for a restaurant on Yelp or searched for groceries on Instacart, Elasticsearch is the engine that is powering that search. So search is an experience. And whether you're searching for a documentation or your favorite show, you expect fast and relevant results no matter the scale. In the first workshop, we talked about how Elasticsearch allows you to get fast search results at scale. And today, we'll talk about the relevance aspect of the search. So we search for things on a daily basis, and as developers, search is our lifeline, right? So whether we're fixing a bug or building a certain feature, we go straight to the search bar and hope that somebody has already figured it out and shared it online. And it's really frustrating when you're searching for an answer, you're not quite getting what you're looking for. And that is what relevance is all about. So when you search for something on your app, you want results that are directly related to what you're searching for. Which brings us to question, well, how do we measure the relevance of our search results? Now, 2 factors we'll focus on are precision and recall. So let's delve into these a little bit more. As a quick review, we know that Elasticsearch is a search engine, and it allows us to store, search, and analyze data. And it stores data as documents. And documents that share similar traits are grouped into an index. Now, when you search for something, Elasticsearch retrieves relevant documents. Then it presents them as search results, which is highlighted in orange here. Now, on this slide, we have 2 diagrams depicting the same thing. On the left, we have documents grouped into an index, and the same thing is shown on the diagram on the right. So the yellow rectangle represents your sample index, and the gray dots are documents contained in that index. Now, I'm going to use a diagram on the right to explain precision and recall. But before we do that, let's go over some terms real quick. So when you send a search query to Elasticsearch, it retrieves documents that it considers relevant to the query. And these are the dots inside the white circle. And these are documents that Elasticsearch sends back as a response. And some of these retrieved documents are what you expect to see in your response. And these are known as true positives. Now, you probably had an experience where when you searched for something and some of the results were not relevant to what you were looking for. And these are known as false positives. So these are irrelevant search results that were retrieved by the search engine for some reason. Now let's focus on the dots in the yellow region of this diagram. And these are documents that were not returned by the search engine. And some of them are truly irrelevant to the search query and were correctly rejected by the search engine. And these are known as true negatives. Now, among the rejected documents, there may be relevant documents that should have been returned in the response. And these are known as false negatives. So earlier, I mentioned that precision and recall are used to measure the relevance of a search engine. And the term precision has to do with dots inside the white circle. And these are documents that are returned as search results. So precision is calculated by true positives divided by the sum of true positives and false positives. So what precision tells you is what portion of the retrieved data is actually relevant to the search query. Now, recall, on the other hand, is calculated by true positives divided by the sum of true positives and false negatives. So what recall tells you is what portion of relevant data is being returned as search results. So precision and recall are inversely related. Precision wants all the retrieved results to be a perfect match to the query, even if it means returning less or no documents. Whereas recall focuses more on quantity. It wants to retrieve more results, even if the documents may not be a perfect match to the query. Now, the dilemma here is that we want to present really relevant items, but we also want to retrieve as many results as possible. So as you can see, these two factors are at odds with each other, because if you want to improve precision, it might cause a decline in recall and vice versa. So let's recap real quick. Precision and recall determine which documents are included in the search results, but precision and recall do not determine which of these returned documents are more relevant than the other. This is determined by ranking. So when you look at your search result, you'll see that the most relevant results are at the top and the least relevant are at the bottom. And this ranking or order is determined by a scoring algorithm. So each result is given a score, and ones with the highest score are displayed at the top, whereas ones with the lowest scores are displayed at the bottom. Now, score is a value that represents how relevant a document is to that specific query. And a score is computed for each document that is a hit, and hits are search results that are sent to the user. So the higher the score a document has, more relevant the document is to the query, and it's going to end up higher in the order. Now, there are multiple factors that are used to compute a document score. For this workshop, we'll only focus on term frequency and inverse document frequency. So let's break this down. Now, when you search for something, you type in a search query in the search box. Elasticsearch looks at the query and pulls up relevant documents or hits. Then it calculates a score for each document and ranks them by relevance. So how does this happen? Well, let's talk about how term frequency plays a role in calculating a score. So here we have a search query, how to form good habits. And this query is made up of multiple search terms. So Elasticsearch will look through the return documents and calculate how many times each search term appears in a document. And this is known as term frequency. So if a document mentions search terms more frequently, Elasticsearch assumes that this document is more relevant to the search query, and it assigns a higher score to the document. So let's say we're looking at the frequency for the term habits. And in the field description of the first document, the term habits appears 4 times. In the same field in the second document, the term habits appears 1 time. So in this example, the first document will be given a higher score and end up higher on the search results. Now, when we calculate a score based on the term frequency alone, this will not give us the most relevant documents. And this happens because term frequency considers all search terms to be equally important when assessing the relevance of a document. So let's look at the search query here. We have search terms how and to and form and good and habits. Now, not all of these search terms will help you determine the relevance of a document. For example, the first 4 search terms are commonly seen in many, if not all, documents. Now, if you take a look at the hits, then at the documents highlighted in orange, these documents like how to form a meetup group or good chicken recipes, they do contain some of the search terms, but these documents are completely irrelevant to what we're looking for. But because of term frequency, if these commonly found search terms were found in high frequency in any of these documents are going to end up with high scores, even though they're irrelevant to the query. So Elasticsearch offsets this with inverse document frequency. So with Elasticsearch, if certain search terms are found in many documents in the result set, it knows that these terms are not useful at determining relevance. So when it goes through all the hits, it'll reduce the score for documents with unimportant search terms, and it'll increase the score for documents with important search term like habits. So we just covered the basics of relevance. Next, we're going to fine tune precision or recall of our search results. And we're going to do that by sending queries from Kibana to Elasticsearch. And in the first workshop, I shared that there are multiple ways to access these 2 products. So one option is to use Elasticsearch and Kibana hosted on Elastic Cloud. And unlike the downloaded option, Elastic Cloud handles all the heavy lifting of managing the stack, so you can focus on building your product instead. Now you get a free 30-day trial, and we went over how to get started with Elastic Cloud during the first workshop. Now this time, I'm going to show you how you can download Elasticsearch and Kibana and run these locally on your own machine. Now the downloaded option is free without an expiration date, but you do have to manage these products on your own, and there are additional steps involved. Now, I found that when I screen share on Zoom and show you how to download and run these locally, Zoom slows everything down. So showing you this live is almost impossible. So I create a video for you guys just for this part. But first, let me share the GitHub repo for today's workshop. Uli, will you drop the link in the chat? Now, when you get this link, you'll click on it and you'll see this on your screen. So this repo contains all the resources that are shared during the workshop, and the slides and the recording of this workshop will be included here as well. So if you scroll down to the resources section, you'll see the link to the instructions for downloading Elasticsearch and Kibana. Now, this is a blog that includes links to the download pages and step-by-step directions on how you can download and run these products on your local machine. So this video I'm going to show you will breeze over these steps, but if you need more detailed instructions, feel free to check out that link. Now, I don't expect you to set this up during the presentation. I'm just showing you what you need to do. So if you want to try this on your own, you can watch the recording and get started. All right, so let me get set up here real quick. Let's see. All right. Okay, so I'm just going to gloss over the part about running Elasticsearch and Kibana. Now, a lot of you have completed these steps before we started the workshop, and the step-by-step directions on what we're about to breeze through are included in the repo. Now, so far, I have downloaded Elasticsearch and Kibana from Elastic website, and I moved them to my desktop. Now, I unzipped both products by double-clicking on them, and on your right, what you're seeing is the unzipped folders of Elasticsearch and Kibana. Now we're going to run these two products by using the command line interface. So let's pull up our terminal. Now I have 3 tabs open. So the first tab is running Elasticsearch. So I just CD'd into Elasticsearch, which is located in my desktop. And then I ran the command bin/Elasticsearch. Now you use this command if you're on Mac or Linux. And if you're on Windows, you run bin/elasticsearch.bat. Now, if you are following my blog to learn how to run Elasticsearch on Windows, you could just run elasticsearch.bat. Okay, now click on your terminal and hold Command F, and we're going to look for 9200. Now, you'll see an IP address ending in 9200 here. So what's that all about? Well, Elasticsearch provides a REST API that allows you to communicate with your cluster. And in other words, when you send requests to Elasticsearch, you're sending a HTTP request to this REST API, whose endpoint is localhost at port 9200. So if you see this IP address and don't see any error messages, we should be good to go. Now, just make sure to keep this tab open when you're working with Elasticsearch, otherwise you'll shut it down. Okay, so we just talked about how Elasticsearch provides a REST API that allows you to send HTTP requests to your cluster. So let's make sure we could send a request to the REST API. So in our second tab, I ran a curl command, which sends a request to localhost 9200. Now, if you see this response with information about our cluster and version number of Elasticsearch, that means that our cluster could receive requests. Now, in the third tab, I'm running Kibana, and this is very similar to running Elasticsearch. So CD into Kibana, which is located in your desktop, and run bin/Kibana if you are a Mac or Linux. Now, if you're on Windows, you can run bin/Kibana.bat. Now, if you're following my blog to learn how to run Kibana on Windows, then just run Kibana.bat. All right. Now, if you scroll down, you'll see that the server is running at localhost 5601. Copy and paste that into your browser, and you'll see this interface. So we just downloaded and ran an instance of Elasticsearch, also known as Node. Now, when you start up a node, a cluster is formed automatically, and the best practice is to name your cluster and node to something that is meaningful to you. And the reason you do that is because as your apps get bigger, you may be working with multiple clusters with multiple nodes that are responsible for different tasks. So it's really important that you could differentiate what each one does. Okay, so let's change the name of our cluster and node. So open up your terminal again and open a new tab. Now we're going to CD into Elasticsearch, which is located in our desktop. And then we're going to open it up with a text editor. Now you'll see Elasticsearch here, expand it, and then go to config directory. And then you'll see elasticsearch.yaml file. Now, this file allows you to configure a lot of things with Elasticsearch, but for today's workshop, we're only going to focus on cluster and node. Now, let's scroll down to line 17, uncommented, and we're going to change the cluster name. Now, you can name this to whatever makes sense for your use case, but for our workshop, we're going to name it Elastic_crash course. Now scroll down to node name, uncomment line 22, and we're going to name this CRUD_node. Now make sure to save it and minimize it. Now, we need to stop and restart Elasticsearch and Kibana for this name changes to take place. So go back to the terminal where you're running Elasticsearch, click on the terminal, then hold Control-C. Now this is going to stop Elasticsearch, and then we're going to use the exact same command that we use to run Elasticsearch. Now it takes a couple of seconds for it to start running, so let's give that a little rest. All right, here we go. Okay, so we see the 9200 here. We're good to go. Now let's go to the terminal that's running Kibana. Click on the terminal, hold Control-C to stop Kibana, and run the same command that you used to run Kibana earlier. Now this is going to take a few seconds to load up as well. All right, great. Now Kibana is running at localhost 5601. Okay. Okay, so I'm just sorry about that. 1 second. Okay, so excuse me. So we just downloaded Elasticsearch and Kibana, and these are up and running on our local machine. Now, when you go to localhost 5601 on your browser, it'll take you to this homepage here. So in order for us to explore the relevance of our search, we need to put some data into Elasticsearch so we have something to search for. So if you have your own data in CSV, NDJSON, or log file, it's really simple to get data into Elasticsearch. So scroll down on the home page and click on Upload a File option. And for our tutorial, I'll be using a news category dataset from Kaggle. And this dataset contains news headlines from HuffPost from the year 2012 through 2018. I included the link to the dataset in the GitHub repo, so if you want to try it out on your own later, you know where to find it. Just make sure to download and unzip the dataset first. Then drag and drop the dataset here. And once you do that, Kibana will give you an analysis of the first 1,000 lines of your data and give you a summary of your data set. So if you look at our file content, you'll see several documents of news headlines under different categories like crime or entertainment. And under summary, you'll also see that our data is in NDJSON format and the time field is date. And when you scroll down, you'll see the field section. And in this data set, each document contains fields such as authors, category, headlines, and etc. And we also see some high-level statistics for each one. So scroll down and click on Import button. And this will import your data into Elasticsearch. And when we're pushing data into Elasticsearch, it'll group all documents into an index so we could easily find it. So give your index a name. I named my news headlines all lowercase, then clicked on Import. Then Elasticsearch will take care of the rest. So you have data in Elasticsearch, and you also have Kibana up and running. And Kibana is a UI used to visualize and explore data in Elasticsearch. And for our tutorial, we'll use a Kibana console to search for data and improve the precision or recall of our search results. So click on the menu icon in the upper left corner. In the drop-down menu, scroll all the way down to Management section and click on DevTools. And this will pull up the Kibana console. So click on Dismiss and delete the default query here. And now we're finally ready to get started. All right, so let me get set up here real quick. All right. Okay. So I have two windows open side by side. On the left, I have the Kibana console, and on the right, I have our workshop repo. And we have two goals. One is to search for information, and two is to fine-tune precision or recall of our search results. And we'll be using Elasticsearch and Kibana to get these done. Now, we just got data into Elasticsearch, so all we have to do is to use Kibana to send search queries to Elasticsearch. So let's start by exploring our data first. And when we added data to Elasticsearch, it stored our data in an index called news headlines. And we want to get a feel for our data. So knowing what our document actually looks like or how many documents we have would be really helpful. Now there's a query that gets you that information. So go to your repo and scroll down to search for information, then down to retrieve all documents from an index. Now for every request we'll go over, I included the general syntax for you here, so you can customize this for your own use case. But for our tutorial, we'll use the request shown under example. So what we're saying here is get search results from index news headlines. So let's copy and paste that into our console. Make sure to select it by clicking on it. Then you'll see this dark gray bar over it. Then click on this green arrow here to send the request. Now what this does is it'll give you information of all documents in the news headlines index. Now in the right panel, you'll see search results from Elasticsearch. So if you scroll down to line 16, hits, it gives you a sample of 10 search results by default. So let's scroll through and see what we have here. Okay. So this document is from Index News Headlines. And if you look at field source, you'll see all the fields that this document contains. So for example, it shows you the date this article was published in, the category it belongs in, the headline, and etc. So with this search request, we get a general idea of what a document looks like, so we know what we're dealing with. So let's see how many documents that we have. So go back to line 10 and you'll see hits. Now it tells you that the total value of hits is 10,000. And by default, Elasticsearch limits the total count to 10,000. And this is done to improve the response speed on large data sets. To see if 10,000 is the exact total number of hits you have, then check the relation field below. Now, if you see EQ here, that means that the value is equal to the total number of hits. But we see GTE here, which means that our number of hits may be greater than equal to 10,000. So let's say we want to know the exact total number of hits. So to do that, look at your repo, scroll down to get the exact total number of hits, then down to example. So this is almost identical to the request that we just sent. So we're saying get search results from news headlines index. By the way, I want the exact total number of hits in the results. So let's copy and paste that into our console. Make sure to select it and send. Now, if you scroll down to hits, you'll see that the value now is 200,853. And if you look under relation, we see EQ means that this is the exact total number of hits. So we have over 200,000 article headlines, and we want to find interesting patterns in our data. But it's hard to know where to even start. So one way to narrow it down is to search for data within a specific time range that you're interested in. So let's scroll down to search for data within a specific time range, then down to example here. Now, there are two main ways to search in Elasticsearch. These are queries and aggregations. So queries tell Elasticsearch to retrieve documents that match the criteria. And right now, we're searching for documents that match our time range criteria. So for our use case, we need to send a query. And this is a query that we're going to send. And we're saying get search results from news headlines index. Now, I'm querying documents from a certain time period. So the type of query that I'm sending is range. And the following are the criteria for documents in my search results. Now, I want you to look at only the date field and pull up all documents between these two dates. So let's copy and paste that into our Kibana console. Make sure to select it and send. Now, if you scroll down to hits, you'll see that we have over 8,000 articles here. And if you were to look through all of these documents and look at the date field, you'll see that all the search results would have been published between these two dates that were specified here. So how can we explore our data even further? Well, when we look at our documents, you'll see that our documents belong to categories like media or parents. So to explore our data further, it'd be really helpful if we knew what type of news categories exist in our data set. So let's scroll down to the aggregations. So remember, there are two main ways to search in Elasticsearch. These are queries and aggregations. And queries are used to retrieve documents that meet a certain criteria. But in this case, we're not interested in grabbing documents. What we want to know is the type of news categories that exist in our data set. So to get this information, we need to analyze the data and get the summary of categories that exist in our data. And this type of search is known as aggregations. So this time we'll send an aggregations request. So turn to your repo and scroll down to example. Now this aggregations request is pretty similar to the query request that we just sent. So we're saying, hey, get search results from news headlines index. By the way, this is an aggregations request. And I want the analysis report to be named by category. And I want you to run an analysis on the following term. And that term is field category. And bring me up to 100 categories if you got them. So let's copy and paste this into our console. Make sure to select it and send. Okay. So let's go to line 10. You'll see this downward arrow here. So when you click on this, it'll minimize hits and you'll be able to access aggregations report named by category. And if you look under buckets, you'll see an array of different categories that exist in our data set. Now, it seems like we have politics, wellness, entertainment, travel, the list goes on and on. And each category has a document count, which tells you how many articles that have been written under each category. So now we have way more to work with. So let's scroll down to combination of query and aggregations requests. So it seems like the category entertainment has a lot of articles. So I want to explore that a little bit more. So, what if I wanted to identify the most popular topics in the entertainment category? Now, this is a combo of both query and aggregations requests. Because first, you got to pull all documents from the entertainment category. So, you got to query the data first. Then you have to analyze query data and give the summary of the most popular or significant topics in the entertainment category. So scroll down to example, and this is a request that we're going to send. So get search results from index news headlines. First, I'm sending a query request here. I want you to query all the documents that match the following criteria. So pull all documents from a category called entertainment. Then run aggregations on the query data and name this report popular in entertainment and give me the summary of the most significant text found in the field headline. So let's copy and paste this into our console here. Make sure to select it and send. Now go to line 10, minimize hits to get access to the aggregations report called popular in entertainment. Now, if you look under buckets, you'll see an array of popular or significant terms that are found in the headlines of the entertainment category. So it seems like the word trailer is pretty popular. It's been written about 387 times. If you scroll through, you see movies a popular term, Taylor, Kardashian, Swift, and etc. So one of my guilty pleasures is watching Keeping Up with the Kardashians. So I'm going to look up articles that mention Khloe Kardashian and Kendall Jenner. So scroll down to precision and recall and down to example. So what this query is saying is get search results from news headlines. And I want you to query all documents that match the following criteria. Now pull up all documents that have the terms Khloe Kardashian, Kendall Jenner in the headline. So let's copy and paste that into our console. Make sure to select it and send. Now you'll see that we got a total of 926 hits. So let's look at the search results. Let's look at the first one in the headline field. You'll see Kendall Jenner and Khloe Kardashian mentioned in the headline. So this is really relevant. Let's look at the second headline. This one only mentions Kendall Jenner. Okay, let's just scroll down a little bit further. Okay, so this one has Kendall Jenner, but instead of Khloe, it mentions Courtney. So kind of relevant, but not quite. Now the next one, it mentions Nick Jonas and Kendall Jenner. So not quite what we're looking for. So our search results returned a lot of articles that mention some of these search terms, but these are not perfect matches to the query. Well, why is that happening? Now notice that our search query has multiple search terms like Khloe or Kardashian or Kendall or Jenner. Now by default, the match query uses an OR logic. So with this query, a document is considered as a hit if it contains even one of these search terms in the headline. Now, earlier, we went over the concepts of precision and recall. So I have a question for all of you. So is this query better for improving precision or recall? I want you to type the answer in the chat box. I'll give you guys a few seconds to answer here. Okay, so I see a mix of answers here. Now, the correct answer is recall. So by default, our match query uses an OR logic. So if a document has at least one of these search terms, it's going to be a hit. And because of that, we have high recall because we get an increased number of loosely related hits coming our way. Now, what if we wanted to increase precision instead? So let's scroll down to increasing precision and down to example. Now, we can increase precision by adding an AND operator. So we're using almost identical query that we sent, except that we added an AND operator. And what this is saying is only pull up documents that contain all of the search terms in the headline. So let's copy and paste this into the console. Select it and send. Now, with the previous query, we got 926 results. But with this query, we got 1. So when you scroll down to this one search result that we got down to the headlines, you'll see that all 4 search terms are included in the headline. And this is a perfect match. So we definitely improved our precision for sure. But it feels like with our first query, we widened our net too much, and we're getting a lot of loosely related search results. But with our second query, we were way too strict and got 1 match. So is there a way to land somewhere in between? And the answer is yes. So we can use minimum should match parameter. So scroll down to that section. Now, this parameter allows you to specify the minimum number of terms a document should have to be included in the search results. And this gives you more control over fine-tuning precision and recall. So let's scroll down to the example. Now, this query is almost identical to the query we just sent. Now, we just replace the operator and with minimum should match parameter and set it equal to 3. So what we're saying here is for all the hits, at least 3 search terms must be included in the headlines. And of course, you can change this number however you see fit. But let's copy and paste this into the Kibana console. Make sure to select it and send. Okay, so now we have 6 results this time. So compared to our last query, we did improve the recall. Now, if you look at the documents, let's see here. The first one in the headline, we got all 4 search terms. That's good. The second one got 1, 2, 3. The third one, we got 1, 2, 3, 4. So at least 2 articles are precise matches to the query. So we improved our precision here as well. So the minimum should match parameter is a way to narrow the net without being too strict. So this is a good parameter to use when you're fine-tuning precision and recall. So, okay, those are all the queries that I got for you. We went over a lot. So let me see if you guys had any questions in the Q&A. Okay, let's see. Okay, so Benjamin asked, we're sending queries through the console in these examples. Yep. I'm guessing in a live system, these queries are sent via a REST API using an HTTP GET with body. Shouldn't this be a post? Hey, Benjamin, could you clarify? I'm not quite sure what you mean by send via a REST API. So like what happens in a live system is that you have codes that sends an HTTP request to a REST API for Elasticsearch, and that's how you communicate. And I'm not quite sure what you meant by using an HTTP GET with a body. Shouldn't this be a post? Which request are you referring to?
Hey, Benjamin, I just allowed you to talk so you can elaborate more your question to Lisa. You just have to unmute yourself.
Okay, and then also Kei-san said using get to payload feels a little strange, same feeling. So as far as I know, these are the syntax that's used for to communicate with Elasticsearch. So I'm not quite sure what was the logical reasoning behind that. So sorry. Uh,
Yeah, so his microphone is not working, Lisa.
oh,
So I
gotcha.
think he's going to elaborate either on the chat or in the Q&A.
Got it.
Do you
Mm,
see that he posted a
yeah.
comment on the chat?
Yes. He said, I'm not sure how to explain this. Okay. So how about if you have more questions about this, I would be happy to answer it via email. So if you could email me at lisa.jung@elastic.co. I will also put it in the chat for everybody. Yeah, I'd be happy to try to explain a little bit further once I understand the question a little bit better. Okay. Any other questions? Okay. So I guess we'll move on. So, we have another workshop in the series coming up, and we'll be talking about full text queries and how we can combine queries to answer more complex questions. And this is happening on Wednesday, February 24th at 12 p.m. Central Time. And the link to the event page is included in the repo. Oh, okay. Now, if you have questions about Elastic, the discussion forum is a great place to get your questions answered. And we have a community of developers and developer advocates that answer questions on this platform. So feel free to post your questions here. Now, last but not least, I often blog about Elasticsearch. So if you prefer to learn by reading instead, be sure to check out my blog. All right, so that's all I got for you. So thank you so much for coming, and I'll see you soon.